Hello, my name is Yong Wei, working at University of Science and Technology of China. My recent research focuses on the geometric flows and applications, including the geometric flows of hypersurfaces and the geometric flows of G2 structures. In my talk, I will discuss some results on the curvature flows of hypersurfaces and their applications in the proof of geometric inequalities. I would like to thank Professor Huojun for the invitation and hope all of you enjoy the event. Thank you.
Hi everyone, my name is Kwok Kwong and I'm from University of Wollongong in Australia. So we have a lovely campus, so you're welcome to visit us anytime. Of course, after the pandemic. And I hope everything will be back to normal soon. And I would like to thank Hoju for invitation. And this is actually my first time to give a talk by recording a video. So I'm going to talk about high-order vertical inequalities, isoperimetric deficits, and Minkowski type inequalities. So this is based on my joint work with Hoju, and you can find our paper on arXiv. So the first part of my talk is going to be fairly elementary. I'm going to say something about the isoperimetric inequality on the plane and on the proof of the isoperimetric inequality using the Wertinger's inequalities. And then I'll give some high-order generalization of the Wertinger's inequalities and use them to obtain some high-order isoperimetric inequalities. And then for part 2, I'm going to say something about the generalization to high dimensions and obtain some high-order Wertinger's actually Poincare type inequalities for sphere, and then apply them to give some stability results for Minkowski inequalities and some inequalities involving the mixed volume.
Hello everyone, my name is John Ma and I am a postdoc in the University of Copenhagen in Denmark. I'm very happy to meet all of you on this online conference, and I'm interested in differential geometry and geometric flow, and in my talk I will give an introduction to Asian solution of curve shortening flow, and in particular I will discuss the construction of a compact Asian solution that I constructed recently. Thank you.
My name is Donghui Seo. I'm a postdoctoral researcher in GIST, which is located in southwest area in Korea. I'm studying spectral geometry, especially for Steklov eigenvalue problem. In my talk, I'm going to talk about a shape optimization result for first Steklov-Dirichlet eigenvalue. We consider two-point homogeneous space as our ambient space, and we will give a proof of the main theorem using an idea of Newton's shell theorem and some comparison geometry. I hope you enjoy my talk and our conference. Thank you.
Hi everyone, my name is Marcos Cavalcante. I'm associate professor at the Federal University of Alagoas in Maceió, Brazil, which is more or less around here on the coast in the northeast of Brazil. I'd like to say that I'm very happy to be participating in this meeting. I'd like to thank especially my colleague Hu Julie for the kind invitation. Thank you very much. My research focuses on different aspects of differential geometry, especially on submanifold theory, like minimal and constant mean curvature surface, but also in spectral geometry, conformal geometry, and nonlinear PDEs on Riemannian geometry. In my talk, I will explain you the definition and the notions of the stability index of minimal and constant mean curvature surface. I will try to explain how this integer, it's a non-negative integer, is related with the topology of the surface. In the main theorem, in a joint work with Darlan and Oliveira, we showed that in the case of closed constant mean curvature surface, either in the Euclidean space or in the unitary sphere, the stability index is bounded from below by a constant times the genus of the surface. At the end of this talk, I will show you some few words in the case of free boundary CMC surface. I hope all of you enjoy this talk. Thank you very much. Kamsahamnida.